Alrighty, so we're going to continue this morning's work by once again adding my two fractions, except this time I'm going to create visual representations of them. And what I mean by visual representations are models that help us see the work a little bit more. And so I'm going to start off with our tape diagram. First thing I want to do is draw two tape diagrams right next to one another. One in which shows 3/4 and the other one which shows 6/8. So if I'm drawing out a tape diagram to represent 3/4, the first thing I'm going to do is I'm going to partition this tape diagram into fourths, right? Because my denominator tells me how many parts I have in this whole. And now my numerator tells me how many are shaded, or how many there are, I should say. So 3/4, right? I'm going to do the same with 6/8. However, how might I want to partition the second tape diagram? How many equal parts should I draw out? Yep, and so I should have 8, right? I have 8 pieces or 8 parts. Okay, now how many am I going to shade in? 6, yeah. Now notice, because our parts are different in size, right? Our parts are different in size. We want to find a way to make sure that they are the same in size. And so I think to myself, well, is there a way that I can partition my fourths to get me 8s instead? Or is there a way that I could partition my fourths so that I have an equivalent of 8s, right? Similar to the work that we did just now of finding a common denominator. So notice this fourth and these 2/8 are about the same size, right? And if I think about it, yep, 4 times 2 does equal 8. And so if I partition my fourth into 8, I'm pretty much just partitioning each fourth into half. And I'm doing this using a separate color to show this, right? And so now that I know, initially we had 6/8, and initially we had 3/4. However, by partitioning each fourth into half, I now have 1, 2, 3, 4, 5, 6, 6/8. And so again, friends, going back to this morning's work, I'm now instead going to, now that I have like units with like denominators, right, I'm going to add those together. And so my denominators don't need to be added together. I just have 8/8, right? And that equals to 16. However, 6 plus 6 equals to 12. Okay? I can now use a number bond again to express my sum, right? Because any time that I have, wait a minute, what happened here? 6/8 plus 6/8. I caught my mistake. Sorry, friends. Sorry. I'm here doing my mistake in front of you. I apologize. 8 plus 8, we don't need to add. Why? Because my denominators haven't changed, right? I have 8 and I have 8. And so the 8 stay the same. However, I add my numerators. 6 plus 6 equals to 12. I was skipping way too ahead. And now I have 12/8. I apologize. Again, we don't add our denominators. We only add our numerators. Last but not least, we want to make sure that we represent this improper fraction, right? When the numerator is greater than the denominator, we need to figure out a way to express it as a mixed number. And so we're going to do this by thinking of, again, I'm doing the same work. How many wholes are in 12/8? I have 8/8, which is equivalent to 1 whole, and then I have 4/8. So I can express this as a mixed number by rewriting it as 1 and 4/8, right? And that's pretty much it. So that's one visual representation. I'm going to pause the video and I'm going to show the next one.